Right, Matrix, let's look at the concept of what we call a function. Okay, what is a function? A graph that is a function, and this is actually quite easy. I'm going to take, for example, the graph of y equals a half x squared, which of course is a parabola, and we're going to draw it, and I'm going to pick some x values and then illustrate what we mean by a function. Okay, so suppose I choose x as, let's say, -2, 0 and 2. I've chosen those at random, so, and I'll show you now why. If you look at x being, of course, -2, what would be a half of -2 all squared? Well, that is a half of 4, which again is 2. Now that avoids, if x is sort of 1, you're going to have fractions, so I'm going to try and avoid fractions here. If, of course, x is 0, well, that's no problem, that's just 0. And if x is 2, well, what do we have there? That's going to be a half of 4, which is, again is 2. Now, I want you to notice something. If we draw this graph, if I go up and I have a look at this, you will notice that the x value of -2 is associating with one y value 2. The x value of a 0 associates with one y value, and that 2 associates with one y value. Now, if you look at the graph, if we just draw this, if we bring this up quickly, what I've got is a very interesting situation here. If I plot the points, okay, what would they be? That would be x is equal to -2, so that will be -2 there, and the y value is 2. This is 2 there, and that's 0. Now have a look at this. The 1x is associating with the 1y. Okay, that x is associating with one y value, and the 0 associates with 0. When you draw the graph, remember you always plot these points. That would be -2 and 2, that would be 0 and 0, and that will be x is 2, 2. Now notice 1x associates with 1y. If you use a little ruler, and this is quite a classic, if you take a ruler and say you take the ruler and you move from left to right, so you're going to come down like this. As the ruler moves, do you notice it only cuts the graph only ever at one point? So as you move that ruler through the graph, it only cuts at one point. Do you notice that? In other words, if you go to that point that it cuts, 1x relates to 1y. So a function is a graph really where this ruler cuts the graph. As you move from left to right, like in that direction, this little ruler will only cut the graph once. It never cuts twice. 1x is associating with 1y. Okay, this graph is what we call a function. Okay, but you might be saying to me, well, what is a graph that's not a function? Okay, let's have a look at this. I'm just going to move this up and let's talk about it. Right, look at this graph here. Now, I'll explain to you what a graph that's not a function is about. Have a look at this. If we pick some x values here on this graph, this will be x is 2 and y is 2. So x is 2 and the y is 2. If you look at that, so the x is associating with that y value. But notice the same x, if you go down here, is associating with -2, and then we've got 0, 0, which is not a problem. But you'll probably notice, if you notice this here, you've got the x value associates with the 2 and the -2. 0, of course, just associates with 0. Now, people, when this happens, the graph cannot be a function. If you take a ruler and you move that ruler from left to right, notice it starts cutting the graph twice. Now look at this here. As it moves, there's 2 points at which it cuts. The 1x is associating with more than one y value. Now the moment that happens is the graph is not a function. And the test is, if you take a ruler, move it from left to right, the moment it cuts at any stage that that ruler passes through the graph, like at 2 points or 3 points, then the graph is not a function. In the previous one, if the parabola was standing up like that, there would never be a problem because your ruler would only ever cut once. As it moves from left to right, you're only ever cutting it once. This is a function, but not a graph like this where a ruler cuts across it twice. Look, it cuts there and cuts there. That is not a function. Okay, it's called the vertical line test, and you can test a graph by doing that. Now, if we explore this a little bit, let's take this further. I'm going to give you a graph to sketch. Let's have a look here. For example, if I told you let's have a look at the graph of fx is equal to x squared. Now we know this is a function because if I had to draw this graph and I had to get its inverse as well. So let's have a look here. Say I had y equals x squared. There's no problem with this graph. You could actually easily draw that. No problem. If you pick some x values and let's say minus 1, 0 and 1, and you square minus 1 squared will of course give you 1, 0 squared is 0, and 1 squared is 1. It'll be easy to draw that graph. This is the graph of f. But now what about the inverse of this graph? Okay, let's have a look. What do? We swap x and y around. Okay, we swap x and y around. Now, in other words, what I'm going to do is I'm going to keep those x values and those y values, but I'm going to make the x values become the y values, and the y values here become the x. This is the inverse graph. And if we draw this graph, something interesting, if we take this graph and we draw it, let's compare it to this graph. Okay, now let's draw that. Okay, if we draw the first graph, let's just go up and have a look at it there. What do we know if we look at that? If we take this, let's just get some coordinates here. We've got x is minus 1 and 1. So if x is minus 1 and 1, there's that point, negative 1 and 1. This is the graph of f. Then we've got here 0, 0, and this would be x is 1, y is 1. If you have a look there, 1, 1. Okay, what about the inverse graph? Let's have a look at that. The inverse graph, well, if we draw that here, it's going to give you x is 1, but y is negative 1. So that will give you this point, 1, negative 1. Okay, and then 0, 0 and that. Now this is the graph here of the inverse. Now notice the graph of f, if you take a ruler and cross it, and move across the graph, you're only going to ever hit or cut the graph in one point. So f is a function. But unfortunately, have a look at this graph here. If you had to take a ruler, if you look at the f graph, the f minus 1 graph, if I go through here, look at this, say I hit there, I go through those 2 points like that. Look at this, I've actually got an x value, an x, 1, associating with 1 and negative 1. The little ruler always, as you move from left to right, is going to cut the graph in 2 points. Now immediately the graph of the inverse is not a function, Okay, so that's a huge problem. So the big thing that we want to do in the world of maths is if the original graph is a function, we want its inverse to be a function. But how are we going to do that? How are we going to establish that? Well, let's look at the x squared graph and see what we can do. If I look, for example, here, now let me say, for example, I said to you, if you took y equals x squared, that is your normal f graph, your function. Okay. It's your original one, it is a function, no problem. Okay, that's the graph of f. What I could do is, they call it restrict the domain. Now the domain would be the x values. So what I could do, if you look at this graph here, I could draw it like this, okay? I could say, what I'm going to do is, I'm going to draw the graph of f, okay? But what I'm going to do, instead of having the whole graph, I'm going to remove some parts of it. So remember, that's the positive x, positive y. What I'm going to do is I'm going to restrict my x. I'm going to say x must be bigger than or equal to 0. So my x would be in this region here where x's are positive. I don't want negative values. So what I'm going to do is I'm going to restrict my x values. So I'm going to say x must be positive. Now when that happens, essentially what you're doing is you're actually removing this piece. Okay, you're removing that piece from the graph. Okay, and if we put it in a little dotted line to just indicate where it was there. Okay. Now, if you take the inverse of this graph, it kind of looked like this. Okay, now notice it's going this way. Now, when you restrict, for example, in other words, you now say, well, the y's must be positive because you're looking at the inverse. The y's are positive, that would be in this region for this inverse graph here. Now, in other words, what I'm going to do is I'm going to scrap this piece here at the bottom. And because if I've scrapped that, I've got that piece where x is positive, and then this one will be the other one where, of course, if you then simply place, if you go back to the pen and you just draw that in there, you'll notice that this graph looks very functional to me. So the f graph, if you look at that, f graph is a function, this one's a function, the ruler only ever cuts once, and likewise with the inverse graph here. So in this case, f and its inverse are going to be functions. Okay, that is such an important concept that we can use. Of course, there's another way you could do this as well if you want to. Instead of doing that, what you could do is you could say, okay, if I take my graph of my original function f, okay, there it is. It's a function. And then what I do is I'm going to draw my inverse graph there, which is not a function now. This is the inverse, but it's not a function. What I could do for this graph is, what if I make the x's negative or naught, which means that the y's are negative if you look at the inverse. So that would mean that if your x's are negative here, you're going to scrap this little piece here, that one. Okay, so you're not going to have that. You're going to have a little thing like this. There will be your graph. Okay, now likewise, where would the y's be negative for the inverse? Would be down here. So I'm going to scrap this one over here, this piece there. Now look at this. You've got two situations there. Now your inverse graph will be itself a function. Okay, so there's the inverse, which would have looked like that. And you've now picked this part. This is where the x's are negative. They're in this region here. And this is where the y's are negative. So you've restricted the x values of the domain of the original function. And by the way, with the quadratic function too, if I go back here and look at this, you can of course also solve for y here. So this would be, remember, if you square root both sides, it's plus minus the square root of x is equal to y. So the f minus 1x could be equal to plus minus the root of x. Okay, and also very importantly, when you go down to this one, if you remember here, if we look at this top version of the inverse, that piece would be the positive version, and that piece could be the negative version there. Okay, so there we go. So when you look at the restricted graphs here, with this one, the inverse graph, that one there would be, of course, the positive root x. How's that? That's the graph of the square root x. And this would be negative root x because your y is negative. So that's very, very important in the game of dealing with restricted graphs.